Welcome to my channel Good Mind Gyan. Today we are going to study about elements, compounds and mixtures. ICSE Class 8, Chapter 3. This is a table which explains about the classification of matter. You already know what is matter. Matter is anything that occupies space and has mass. Matter can be divided into two types: pure substances and impure substances. Pure substances can be classified as elements and compounds, and elements can further be divided to metals, non-metals, metalloids, and noble gases. Similarly, impure substances, that is the mixtures, can be divided into two types: homogeneous mixtures and heterogeneous mixtures. So now in this chapter we are going to study all about elements, compounds and mixtures. What is a pure substance? A homogeneous material which contains particles of only one kind and has a definite set of properties is called a pure substance. There are various examples, example iron, silver, oxygen, sulfur, sodium chloride, magnesium oxide, carbon dioxide. All these are pure substances. They cannot be divided further. Hence they are called as pure substances, and they are only made of one kind, having definite set of properties. So what are the characteristics of a pure substance? They are homogeneous in nature. Definite set of properties, that is the properties are different from the properties of other substances. And the composition cannot be altered by any physical means. What is an element? A pure substance which cannot be broken into two or more simpler substances by any known physical or chemical means is called an element. In the periodic table, there are many elements, okay? The normal elements do not give radiations. 82 elements are the non-radioactive elements, that is, they do not give harmful radiations. Whereas we have the radioactive elements also. There are 36 elements which are radioactive and they give harmful radiations. What are the characteristics of elements? The elements are made up of only one kind of atoms. Let us take any one example. For example, gold. Okay, they will contain atoms. They will be made up of only one kind of atoms. Like all the atoms would be gold. Any element cannot be broken into two or more smaller parts, exception in nuclear reactions. Atom is the smallest unit of an element, found in free state or in the form of their compounds. Some elements can be prepared artificially by nuclear reactions. Elements can be classified into metals, non-metals, metalloids and noble gases. Now, children, let us see what is a compound. You already have seen what is an element. Now, what is a compound? It is again a pure substance which is composed of two or more elements. So, when two or more elements are combined chemically in a fixed proportion by weight and can be broken into smaller parts or elements by chemical methods only. So, here in a compound, you will find that it is a pure substance composed of two or more elements. Let us take an example of water. Water, the formula is H2O, where you have two elements. One is hydrogen and the other is oxygen. Now, water is a compound which is made with fixed proportion by weight. Like you have two parts of hydrogen and one part of oxygen, and they can be broken into smaller parts or elements by chemical methods. So you all know that water can be divided, like you can separate hydrogen and oxygen from water by chemical methods only. You cannot just take water and separate it. You have to use chemical methods like electrolysis of water can be done. Okay, by using a voltmeter. You have to take a voltmeter, fill it with water, acidified water. There will be a circuit which needs to be completed. Electricity would be passed through it. Then there would be electrodes. Okay, one is the cathode and the anode. Inverted tubes on the platinum electrodes. So what will happen is when the electric current is passed through the acidified water, the water will decompose to give you hydrogen and oxygen, hydrogen at the cathode and oxygen at the anode. So in this way, the compound can be broken into smaller parts or elements by chemical methods. And as I told you, there is a fixed proportion by weight. That is 2 parts of hydrogen, 1 part of oxygen. Next, so what are the characteristics of a compound? The nature of elements constituting a chemical compound remains same. A pure chemical compound is homogeneous in nature. Now, homogeneous means it will be uniform. You cannot differentiate it into 2 layers. It's a chemical compound which is homogeneous in nature. What are the characteristics of a compound? A chemical compound cannot be broken down into 2 or more different elements. It can be synthesized from these elements by chemical means. A chemical compound has a fixed composition, that is, its constituent elements will combine together in a fixed ratio by weight. So by a fixed ratio by weight, you are able to have it. It will have distinct set of properties which do not resemble with the properties of its constituent elements. What do you mean by this? Like for example, water is a compound having the formula H2O. So hydrogen, if you compare the property of hydrogen and oxygen, hydrogen is a gas, oxygen is a gas, but when both hydrogen element and oxygen element combine together, they form water, which is a liquid. Yes, so the properties are entirely different. The properties of hydrogen are different, the properties of oxygen are different, and when they combine and form a compound water, the properties will be altogether different. That's the reason we are saying that they do not resemble with the properties of its constituent elements. Mechanical separation of elements is impossible. Okay, so manually you cannot separate these elements. For example, if the water is just given to you, you cannot just separate water, that is hydrogen, from oxygen. You have to use chemical methods. Formation of a compound involves energy changes. Now, it will be that there are some energy changes which are taking place. At least energy will be released or an energy will be absorbed. Okay, so when it is the absorption of energy, it is an endothermic reaction which is taking place, and when it is a release of energy, it is an exothermic reaction which is taking place. Now, next part is mixture. What is a mixture? If 2 or more substances, that is elements, compounds or both, they are mixed in any proportion. Now here it is any proportion, not a fixed proportion. In a compound we saw that it was any fixed proportion, but here it will be in any proportion. Do not undergo any chemical change. There will be no chemical changes which will be occurring, but they retain their characteristics. The resulting mass is called mixture. So mixture is altogether different from a compound. Okay, they will be not be in a fixed proportion, they will not undergo any chemical changes, and they will retain their characteristics. As you saw that when we took water, which was a compound, yeah, hydrogen, which was an element, had different properties, oxygen had different properties, and water had altogether different properties. But here you will find that they will retain their characteristics, and the resulting mass would be a mixture. Now, there are different types of mixtures. You can classify them into heterogeneous mixture and homogeneous mixture. What do you mean by a heterogeneous mixture? A mixture in which various constituents are not mixed uniformly is called heterogeneous mixture. For example, a mixture of sand, salt and water, sulfur. So when you take these mixtures, okay, you will be able to identify salt, sand and sugar. You will find them that they can be identified. So they are not uniform. You can see them in different layers. Whereas in a homogeneous mixture, it is a mixture in which different constituents are mixed uniformly and it is called a homogeneous mixture. For example, if you take brass, brass is an alloy. Okay, it is a alloy which is a combination of two elements, that is copper and zinc. But when you combine them, you get brass. So you won't be able to identify copper and zinc in this case. So it is a homogeneous mixture. So whenever you are not able to identify the two layers, then it becomes a homogeneous mixture. Otherwise it is a heterogeneous mixture. So all the salt solutions are homogeneous because you won't be able to identify it. For example, if you take a sugar solution or a salt solution, when you add sugar or salt in the water, it will completely dissolve in that water and you will get a solution which is dissolved. So you cannot find sugar separated from the water. So it's a homogeneous mixture. So all the salt solutions, all the salts which dissolve in the solvent would be homogeneous mixtures. It depends on the solvents as well. So this is all about the kinds of mixtures. So now what are the characteristics of a mixture, children? Now you have a variable composition, that is their composition won't be fixed like a compound. Okay, they will vary. The elements which are used will have different compositions. It won't be the same. Physical change, okay, and like the you will see the physical change in the elements. No specific properties. Okay, it won't have specific properties. Homogeneity will be observed here. Like if it is homogeneous or heterogeneous. Then the separation, you have to check the what in what way you can separate the mixtures, and there will be no energy changes taking place in the mixture because there is no chemical change taking place here. So what is the difference between a mixture and a compound? Let us go stepwise. Let us check the nature. The mixtures do not combine chemically, whereas a compound, you will find that they unite chemically. Okay, then if you check about their structure, they are generally heterogeneous. Some mixtures are homogeneous. Okay, so generally they will be heterogeneous, means you will be able to identify 2 or 3 layers. It depends on how many elements are used. Okay, so it will be a heterogeneous mixture. Very rarely it will be homogeneous. Whereas in case of a compound, they are always homogeneous. Now let us go to the composition. Any ratio, that is, they will have a variable composition. The ratio is never fixed. Whereas in a compound, the ratio will always be fixed. What is the difference between a mixture and a compound? Next property is, we are going to study about properties. The mixtures will retain the individual physical and chemical properties, whereas a compound, the properties will entirely be different from the properties of its constituents. As I told you and gave you the example of water, right? Water is a liquid state, whereas hydrogen and oxygen are gases. But in mixture you will find that the properties will be retained, physical as well as chemical. Next is about the separation of constituents. In a mixture you can separate the constituents by simple methods. Okay, so by using simple physical methods you can separate the mixtures, but it is very difficult or it's impossible to separate the constituents of a compound. You require chemical means or chemical methods. Next comes the energy changes. No energy changes take place in a mixture, whereas in a compound, the energy change is absorbed or given out. Like you will have evolution of heat or absorption of heat. So one of them will be observed. Kinds of mixtures and their separation. Now, what are the kinds of mixtures and their separation? The nature would be homogeneous mixture. You have example, um, alloys, okay, brass fusible alloy, bronze. And the constituents of the mixture, that we have solid mixture. Now, what are the kinds of mixture and their separation? First of all, nature, heterogeneous mixtures. Okay, examples, you have charcoal and salt, whereas and also iron and sulfur. So these are heterogeneous. You are able to identify both. Yes, and the constituents of the mixture are solid mixture. So in this way, you can classify them. Kinds of mixtures and their separation. You have, if the nature is homogeneous mixture and the constituents of mixture is solid and liquid. Example here is common salt in water and iodine in alcohol. So here common salt is the solid and water is the liquid, and in iodine is the solid and alcohol is the liquid. So it's a solid liquid mixture and it is a homogeneous mixture, means it will dissolve in each other. It's going to dissolve. Next, if the nature is heterogeneous and the constituents of mixture are solid liquid, okay, so solid will be sulfur and liquid would be water. So sulfur and water. We also have one more example, sand and water, where sand is a solid and liquid is water. Next, nature homogeneous mixture. The constituents of mixture are liquid mixture. Let us take the example alcohol and water. So here it is a liquid. Again, alcohol is a liquid and water is a liquid, and petrol is a liquid, and also kerosene oil is a liquid. So liquid mixture, and it is homogeneous because it will completely dissolve in each other. So it's homogeneous. If it is a heterogeneous mixture and it is a liquid mixture, we also have oil in water and carbon disulfide in water. Now, what are the principles involved in the separation of components of a mixture? The physical state of the constituents of the mixture. Then you have the difference in one or more physical properties of the constituents of the mixture, and the physical properties are considered in the separation of the constituents of the mixture are, you have density, melting point, boiling point, volatility, solubility, ability of the constituents of the mixture to sublime, magnetic properties of the constituents of the mixture, and the ability of the constituents of the mixture to diffuse. Now we can separate common salt and marble powder by using solvent water. Here you can see this is an experiment where you have taken a filter paper and for doing the process of filtration, and there is a mixture of sodium chloride and calcium carbonate. Okay, so this is a solution which is heated, and after evaporating this solution of a mixture of sodium chloride and calcium carbonate, we can evaporate it to and dry it, and you will find the component which is remaining. Yes, so we can separate common salt and marble powder, that is calcium carbonate, by using solvent water. Yes, this is possible. This is one way of separating the um, common salt and marble powder using the solvent as water. Yes, we have one more experiment, that is sublimation. Okay, here we can separate ammonium chloride and common salt by using sublimation method. Now, what is sublimation? Sublimation is a process in which a solid state directly goes into the gaseous state without going into the liquid state. So here ammonium chloride is a substance which sublimes. Now if we have taken a mixture of ammonium chloride and common salt in a china dish, okay, we have placed an inverted funnel over it and we have tightly closed it with a cotton plug and we have kept it for heating with the help of a burner. What you will observe in this case is the vapors of ammonium chloride will be seen on the inner side of the funnel. Okay, and when you allow it to cool, it will solidify to ammonium chloride. So later on, after it cools down, you can remove the solidified ammonium chloride with the help of a scraper. You can scrape it out. So what happens is, what remains in the china dish is sodium chloride, that is common salt. So what we did here is we had a mixture of ammonium chloride and common salt in a china dish which we separated. Okay, it got separated, we got NaCl in the china dish and we separated ammonium chloride, we got it on the inner side of the funnel which we could separate and take it out with a scraper. So this is the method to separate. Next comes the separation by sedimentation. Children, you all have already studied it in standard 6 and 7, like how you can do this method of separation with the help of sedimentation. What happens in a sedimentation? You have to, like, if you have a beaker which is filled with which is having a muddy water, just for example. So if you just keep that muddy water undisturbed for a few hours, you will find that all the insoluble impurities will be found at the bottom and you will have the clear water at on top. Here in the picture you can see it clearly that this is a water, like you can say it is muddy water, and here after it has settled down, you can see the impurities have settled down at the base and this is the clear water which you get. It's very clear in this diagram. Okay, so in this way you can, what you can do is you can slowly separate this clear water in another beaker. So the process of separating the clear water in another beaker slowly without disturbing the sediment. Now this sediment is nothing but the insoluble impurities. When we slowly pour it into another beaker, the clear water, that process is called as decantation. Okay, so here you can clearly see that the clear liquid is separated, the sediment is left behind. Okay, this process is decantation. So it's very clear in this picture now. This is sedimentation process and this is a decantation process. In the sedimentation process, you can see the sediment at the base with the clear liquid at the top. And when we poured it into the beaker, you have a clear liquid here. Yes, and how to do this process? You have to slowly do it, slowly pass on the clear liquid in this beaker with the help of a glass straw, and the sediment will remain in the beaker. Sediment can be anything. Here it is mentioned sand, but whatever liquid, if it is a muddy liquid, the muddy parts or the insoluble impurities will remain in the other beaker and the clear water will be passed on in the other beaker. Again, we can also separate by a simple method, that is filtration. You can separate the mixture of water and sand. For example, you will place a beaker below, you will place an inverted funnel. Okay, a funnel, you can take not an inverted funnel, you just take a funnel with a filter paper, pour the solution or the mixture of water and sand, and what will happen is when you do it slowly, the liquid will come down, the clear liquid, and what will be left behind is the residue. So the residue will be collected in the funnel, in the filter paper, and you will get the clear liquid which is called as the filtrate in the beaker. So here in this process you got a residue in the filter paper, in the funnel, and you got a filtrate in the beaker, that is a clear liquid. So this technique can also be used the technique of filtration. Here you can clearly see how we can do the filtration. First of all, the filter paper has to be folded in a proper way. Here the folding is shown with the dotted lines, like you will fold as it is shown here. It will become a half and then it will be just 1/4 part. So that you will place into the funnel and then you will slowly pour the liquid. So this is the method of filtration. What are the advantages of filtration over sedimentation and decantation? It's a quicker process than sedimentation and decantation, and the insoluble solid is completely removed, which is not possible in case of decantation. This is again a separation by evaporation. You can use an evaporating dish, a wire gauze, a tripod stand and a Bunsen burner. You can take the salt solution, heat it on a wire gauze with the help of a tripod stand, and after evaporation like you can separate the salt. We can also use separating funnels. Okay, these are some pictures of separating funnels where you can separate two liquids. For example, if you want to separate water from oil, you can do this. You can use this method of separating with the help of separating funnel. Okay, this we can also separate kerosene oil and water, that is liquid mixtures can be used for separating with the help of a separating funnel. So these are all pictures of separating funnel where you will have a stopcock below. You have to put the mixtures of two liquids in the separating funnel. What you will find is that the tap of the separating funnel is closed in the method and the funnel is clamped. Okay, this is just like a tap. You can clamp it and you can use it. Okay, so what you have to do here, see, this is a separating funnel. Now if you have taken water and kerosene, the water will be down and the kerosene level be on top. Why is it so? Because here you have taken two liquids. Okay, both are immiscible, they are not dissolving in each other. So kerosene oil and water, this mixture, when it is poured in the separating funnel, the mixture is allowed to stand for half an hour or more. What will happen here is the immiscible components of the mixture will separate out into two distinct layers, and the heavier and the denser liquid water forms the lower layer. So the lighter and the less denser liquid kerosene forms the upper layer. So in this way, by using the stopcock, you can separate water. You can bring the water in the beaker and then close the stopcock, and what will remain in the separating funnel is the kerosene oil. So in this way we can use this technique and separate two liquids. Okay, so the conical flask is placed under the nozzle of separating funnel and the tap will be gently opened. The heavier liquid will trickle in the flask or in the beaker which you have taken, and the denser liquid is drained out and the top tap is closed. So this method is very useful for separating two immiscible liquids. Okay, so that's it. So this is the method which can be used for separation of two immiscible liquids, and that is for two liquid mixtures. I hope you liked this video. If you have liked this video, please subscribe, share and comment. Thank you so much.